So I want now to talk about some of the loose ends relating to object-oriented programming for Python. So things I forgot to say that I should have said earlier. So the first one that I've said, I'm pretty sure, is that everything is an object. And if you remember this principle that everything is an object in Python, it will help you understand a lot of things and a lot of how Python actually works. For instance, at some point when I explained the packages, the Python packages, how to take a collection of modules, so a collection of py files, and turn that into a package. So you put them all in the same folder, and you're not quite done yet. You also need to create a file, and this file is called __init.py. And it can actually be kept empty, and that's perfectly fine. You can also put things there. Well, this is exactly needed because the code in that module will become a Python object. So the code in the package, so in the whole folder, will become a Python object, and this __init.py or double_py gives you the constructor for that package. So the whole package becomes an object, and every module starts defining some methods, and the init here helps Python construct the object associated to the package. Okay, so you see a reuse of that double_init name. Okay, so something else I didn't really explain is the bound versus unbound method. So if you remember, a bound method, which is pretty much all the methods we've seen so far, are defined like this. So you have a class, my class, that inherits from object or something else, and then you define a method, and the first argument should always be self, or should always refer to itself and can be called self by convention. And then you have some arguments and you do something. So that's the method definition. But then you call it with your object that is of type my class, and then .my method, and then you enter the arguments. But you don't actually enter self. You don't do my method, open bracket, my object, comma, argument 1, argument 2. And the reason is that my method here is a bound method, and this is what makes this possible. So Python knows, because my method is bound, that it should just substitute this guy in there always as the first argument. An unbound method is a method where you don't have this little shortcut. And this typically occurs if you refer to my class.myMethod. Then Python does not have an instance to plug in. Okay, so this is an unbound method, because if you wanted to use this thing, well, then you would have to do to pass self as an argument. So this would be valid and would do exactly the same thing using an unbound method. So this guy here is unbound. So what I do is I pass my object and then arg1, arg2, and so on. Okay, so it makes direct sense why this works here from this definition, but Python is smart and knows that whenever this situation occurs, it should not only create the unbound version, but should also create the bound version, which allows for this shortcut. All right, so another distinction between different methods. So first, composition versus inheritance. So we've seen two ways to define, to add attributes to a class. So the first method that we saw was composition, and the second method was called inheritance. So let's see the two of them in action here. So B here inherits from A, right? So this is what we just saw recently. But here, C, or the C attribute, uses the C class by composition. So you should think of inheritance as applying whenever you have a is-a relationship. So a land animal is an animal. Okay, so the class land animal should inherit from the animal class. Now, composition is usually associated to an as a relationship. So, for instance, a land animal has a leg. Okay, so if I had the class leg, or legs, then a land animal would use legs by composition. Now, in general, people say that composition is favored, and I tend to agree, because inheritance, as we've seen, or as you will realize, tends to create very vast, complicated hierarchies, and with lots of nested dependencies on the interfaces. So you're always saying, okay, I want the interface of this class to rely on the interface of that other class, where I dump in more stuff. Okay, so if you change the class you inherit from, or at least its interface, you have to change the class that inherited. So that's a dependency that you might not like. The drawback of using composition, which can prevent that, is that you need to define a bunch of methods that you don't get for free. So you get them for free with inheritance. You say, okay, I want the interface of B to use the interface of A, where I add more stuff. So you don't have to redefine the interface of A when you define the interface of B. If you do composition, you do. You have to respecify the full interface of B. So this is the drawback, but it's also good, because it means that if the interface of A changes, then you only have a few methods to correct to be able to maintain the interface of B. So if you want, you prepare the places where those changes need to happen when A changes. So it's really a trade-off, and you have to anticipate how your code might evolve. So now I'll talk about class method versus static method versus instance method. So instance method is what you've seen every time. So it's an instance method is a bound method because what will be substituted in is an instance. Okay, it's the self. So there are other types of methods that are called class method and static method, and the way you specify them is by using those decorator at static method or at class method. But it might not be clear why you would want to do this. So let's see this little example. So this little example will import from math cosine, sine, and pi, and then I'll define my own class for complex numbers. And the way I'll do this is I will not inherit from complex, because that's not possible, actually. Complex is a built-in type, so well, it's possible, but it would become quite complicated. So instead, I'll use a complex number, or a Python complex number, by composition. So I'll define a new attribute, data, that will hold that complex number. So you might ask, why do you want to do that? Because you already have the built-in complex. Well, the reason is that I want to change a little bit the interface of complex, or I want to create a new class that would represent complex numbers with a slightly different interface from the original one. And in particular, this interface should be different in that the constructor, okay, so this part is not different. The constructor takes x and y, the x and y coordinate, if you want the real and imaginary part, and defines a complex number. But it can also have another constructor that will use the r, so the norm, and theta, the argument, but this argument given in degrees. Okay, so from that r and theta, it will create a new instance of the class complex that will have this norm and this argument. Now you can see why this is a class method. This should be a class method because it does not depend on a particular instance. So it does not depend on an instance. Actually, it creates an instance. Okay, so the result here is that it should return a new instance of my complex. So, but it's still, so this does not depend on an instance, but it depends on the class itself. Why? Well, we want to call the constructor of the class to be able to construct a new object of type my complex. So we need to have class as an argument so we can do something with it. Okay, so this is what a class method is. If you want, it's a bound method where what you're substituting is not an instance, but the class itself. So in this case, this is another convention. You don't use self anymore, you use CLS to refer to the class. And so this constructor will take r and theta in degrees and will return class. So here, this is implicitly calling the constructor with r cosine and then theta converted to radians, and r sine with theta converted to radian, because theta was originally given in degrees. So this is an example call you would do. So you would do my complex dot from r theta degree to 160, and then let's access the attribute data, and you would get the complex number here, 1 plus 1.7i. Okay, so the point is that this is a class method because what you have here is the class, not an instance of the class. Okay, and you shouldn't have an instance of the class because you want to define a new instance. You don't yet have an instance. Okay, so that's why it's a class method. And there is also here the static method, toRadians. And toRadians is just a utility function if you want. It's a utility function that just converts from degrees to radians, okay, so using this formula. And it makes sense to have it in the context of the class myComplex because this is where it will be used. But it doesn't need to have all the magic that Python usually puts in methods of the class, of binding, of a bound method. It doesn't need any argument passed here. It just works on its own to do toRadians of some degree, and then it should return the radians. Okay, so this makes sense as a way to call it, but you don't need to have class passed as an argument because it doesn't depend on either the instance or the class itself. So in this case, this is a static method, and this is indicated by this decorator. All right, so this was for some loose ends with Python object-oriented programming, things that didn't quite fit anywhere else to explain them.